Why does it not let me go live here? Manage streams. Prepare to go live. Okay. It's very wonky. Uh, oh, perfect. Okay. Now it worked. Finally.
Okay,
Reverse
great.
side effect. Not very happy with the product. Okay. Now it's working. Now I know
Okay,
it's working.
great. Yep.
Cool. Okay. For those of you who are probably landing here and I just want to like give a quick intro about myself as well. Come from a computer science background. I moved here to the US, did my master's in data science, worked at IBM, then Google, then Microsoft as a data scientist, and now recently, since the time I was in Microsoft, I've moved closer to startup ecosystem, and now I'm part of Fireworks team as a DevRel. Super exciting space, and I've seen like this entire space evolve. Like if you remember 10 years ago, like AI and data science was a completely different beast compared to what it is now. I would say it was closer to statistics than
Yes.
magical applications that we see right now. So it's definitely evolved a lot. And back then, I don't think there was even like a ML engineer or like a AI engineer role. It was either you are building products or you're building models. It wasn't to a point where you're like, oh, the models are so good that you're actually going to put it into production. There were like very few companies, probably like the top tech companies, which had this ML engineering role or people in ML with like that sort of a specialization. But now it's becoming widespread, and a lot of companies are having AI engineer roles. I see a lot of software engineers transitioning into AI engineers, and that's why we wanted to do this live, where we can chat about how things have changed. What's more important is what do you learn now? Like if you're a software engineer now, what are the things that you would learn? So Arvind, like you tell me, you have been like you're also like running ICOs, and you know like you're seeing a lot of projects coming from your customers. What are the kind of tools that you often see that people are using, or what do you use and your team uses that you would recommend to software engineers who are transitioning into AI engineering now?
Right. So that's actually a very interesting question, right? And I feel like the answer will surprise most people in the sense that the tools that we use are tools that, you engineers have traditionally been using, right? They usually like it looks like a programming language, Python, Java, whatever it is, and then you pick a cloud platform that you're usually building on.
Yeah.
And that is actually one of the big changes that I've noticed is that in the AI world, it's since a lot of the inference happens on the cloud, the cloud
Mhm.
platform that you pick is actually something that you think about a little more as you're just figuring out your tech stack.
Yeah.
And for you to actually go out there and build your AI systems, you actually think more about frameworks like LangGraph and so on that can help you build
Yeah.
your AI system. So, those are the main things that, I kind of like think about now as an AI developer. But the fundamental tools that you use to build systems, they remain the same. The concepts and the underpinnings remain the same.
And I'm also like seeing that the entire requirement and I typically like tell people that you need to understand the fundamentals, you need to understand the foundations, but somewhere I go back and I'm like, do we really, like, does an AI engineer really need to understand like how a neural net works? And I feel like, yeah, from like a learning perspective, it's important that you understand the architecture of how the model is. That's when you'll be able to like best optimize it, or like if you're doing like sharding, or you're doing like parallelism, that's when you'll be able to do it better. But I still feel the market has grown so much that there is a part of the role that requires more software engineering rather than you needing to like understand the deep statistics behind how machine learning models work.
No, you're not wrong at all with that observation, right? In fact, so as we both started off as data scientists, right? And you rightly called out that data science is very like based in statistics. It
Yeah.
required you to like actually be a math person.
Yeah.
But what I think has happened with AI is that it's made the barrier to entry like really really low.
Yeah.
It's democratized the technology to everybody. So what that means is you don't really need to be a math person and understand exactly how a neural network is put together, how attention mechanisms work, and so on. It
Yeah.
just suffices that you have the right intuitions, right? And with that, you can actually build a lot. And the main thing that you would be using, the main skill that you'll be leveraging actually today is your software engineering skills. And when we talk about software
Yes.
engineering
Yes.
skills, it's actually not even coding, right? It's more about how to put together systems together. How do you architect, like, the solution that you're, developing? Because even when it comes to coding, I think the AI can help you a long way today.
Yeah,
Yeah.
exactly. That's what we saw during our vibe coding workshop, right? Like with just simple prompts, you can build like end-to-end systems right now, be it like front end, back end stuff. Like I know we are probably not there yet where we can build like truly scalable systems, but it still does most of the work, I feel.
Yes, yes, and also it also depends on the technology stack that you're working with.
Yeah.
I feel like it's because of what is more represented in the internet, like things
Yeah.
like if you're building with a web stack like TypeScript and so on,
Yeah.
then the AI actually does a really good job with that,
Yeah.
right? But then if you're writing your code in like C++ or C or something like that, it's you still there's still some room for development, I feel. Uh, and another thing that we realized, right, as we were working on that vibe coding session, is that again, going back to building web application, even as I was conducting the workshop, I was so impressed with how easy it is to build a website today. So I
Yeah.
actually feel like you're no longer going to have like web development as like a full-time role, freelancers doing web development and all of that.
Yeah.
It's not going to be so much like sort of coding it. It's going to be people who are able to work with AI to like spin things out really quickly.
Yep, yep, yep. I was I know I was discussing this with you early on. Um Back in 2016, I was interning at Microsoft, and this was ML team in India. And I hired in the team which was building like chatbots. And back
Hmm.
then there was this framework called Microsoft Bot Framework. So it used to be still a very manual process that you have to like define uh, what that flow of the chat is going to look like. You have to define the entities. You have to define the intents, and everything that doesn't follow in these categories of like intents and entities, it's going to just say that I don't know what you're saying, you know. And
Yes.
we lived with that sort of a chatbot for the longest time. And I feel now when it comes to like building a chatbot, I can do it with just two things. I need like a LLM API and a prompt of where I need to integrate it. It be it on my website or uh, on my app, whatever it is, and then it's just ready to go just off the bat. Like, sure, if you're looking at enterprise use cases, you will need like some sort of fine tuning to that. But then for most use cases, if I just need a chatbot which runs through and answers question based on my website, I can run it with just like two steps. So I feel like
Yeah.
transition is moved a lot. And you'll probably relate to this because you've seen like both the software engineering side and the data science side. It's right now I feel the market of this entire AI application has grown so much that earlier it used to be software engineers who are building toolkits, like SaaS toolkits. Then there is data scientists who are building like the brain of this, like AI models. And it used to be a very hard process to even integrate any AI models into the applications. It and if you have done that successfully at scale, you're like Google level. That's when you're
Yes.
successfully integrating AI applications scalably. Like otherwise, everything else was experimentation. Like you're just doing A/B testing and stuff. But now there, I've seen people with absolutely no tech background integrate this seamlessly in such amazing applications. And that's one of the interviews I was seeing with y Combinator, that they were talking about like how the transition of companies like startups who are applying to YC has happened in the last few years. And primarily because of this, right? Like you can get the most intelligent model to do whatever you want with just an API call.
Yes.
That accessibility used to not be there.
Yeah, it's really cool to think about it, right? Like, so what has really changed over there is that you have on-demand kind of reasoning and inference in the sense that back in the day when we were doing data science and machine learning work,
Yeah.
right? It went something like this. You would spend 80% of your time just wrangling the data,
Yeah.
and like trying to bring unstructured data to some form of structure that you can use for further modeling. And then
Yeah.
like data scientists would put together some sort of a prototype. That was mostly what I did, build a churn model or something like that and toss it over to the ML engineers, who would then build it to production scale and all of that.
Yep.
But
Absolutely.
now I think the focus has shifted from, kind of wrangling with data to quickly, feeding unstructured data to the LLM, because the LLM is able to, kind of make sense out of it.
Yeah.
So I feel that has been like a huge unlock. For example, just the way you had that experience with your internship at IBM, right? I interned for 2 months at a company called Pega Systems, and I was working on chatbots as well.
Hmm.
And what I was working on was to build a chatbot that could do intent detection in French.
Yeah.
So my entire 2 months of my internship was literally converting English data sets to French using Google Translate and then manually annotating it.
Yeah.
And I can only imagine if I had to do that today with access to LLMs, then that would have gone like that in one day. So
Yeah.
yeah, it's that way. It's been a huge what to say, uh, democratization of this technology. Before, it's only like people, a few people who knew a few skills to could access it, but
Yeah.
now literally anybody who can make an API call can access it and start building cool stuff on top of it.
Yeah. And I just find this example very cool and fun. There was a startup that I was talking to, and they have used this, like, translation technology as part of their product, and it's called Magic Story. And what they've done is, like,
Hmm.
there are parents who want their kids to be multilingual, and they let you generate storybooks from scratch. So now you don't have to go to like a bookstore and like buy off the shelf storybooks. But if you want your kids to be learning certain lessons, you can give a prompt on their tool, and you can describe, like, what your kid likes, what do they prefer, even in details, things like what do they look like. And it's going to generate a storybook, print it, and send it to your home, which looks exactly like your kid, and they relate more to it. And I feel like that product, like prototype to actual implementation, is like so fast, and like every like people from like different backgrounds are like using it to their benefit. And that's something that I find is very fascinating, because as tech professionals, I don't think we are so creative in terms of how the technology can be used. But when you
Yes.
just like give it away to people, give it away to society, and like, just have them go crazy with it, we're like surprised to see like what kind of output we get out of it.
Yeah, absolutely. Um, but then, like, tell me this though, right? I mean, I also feel while we were talking about all the upsides to this kind of democratization, I also do feel that one of the biggest kind of points of consideration when you're trying to build something, an LLM based solution at scale, is cost, right? And usually that seems to be even my experience. The minute you go from some sort of a prototype to building out a product at scale, costs come and kick in
Mhm.
really quick, right? And you have to really have like a thought about, okay, what is the return on investment over here? So
Yep.
I, since you are in this field, you work a lot with this in your role at Fireworks. Like, what is your usual framework for kind of balancing the return on investment versus the the value upside with using LLMs and the ease of development with LLMs?
So I would say, like, there's no single point of answer for like calculating ROIs, because it depends on what kind of company. Like, if you're looking at a
Hmm.
company, say like OpenAI, like you want to become the next OpenAI, where you're serving these models on a subscription basis, it's going to be a journey till you see a ROI. Like, you'll have to have like a freemium product which is available for people to use and get hooked on and see the value, and then get them into like a premium subscription in order to like recover those costs, right? So when it comes to a B2B product and a B2C product, I would sort of have like different mindsets. When it comes to a company that's implementing this as like a B2B product, they
Hmm.
care more about instant ROI. Like, they want to see something before day one. They want to see it on day zero. Like, we don't even want to like put the human hours, or like, spend anything on it, or like even like clear out the product till we know that this is better than the way that we're doing it right now. Like every company has their own process. It might be manual, it might be a combination of manual and rule based system. They don't want to replace that system because the cost of replacing that system and uptraining their uptraining their folks is going to be much larger than just
Yes.
like what is the input output token cost that comes from an API, right? So that takes a lot of like visionaries in order to like take that call, and a lot of people to like take a leap of faith to some extent, where they say that okay, like now I'm going to dedicate like this team and resources in order to build this out and have faith that this is going to end up being better than what we have currently. Because it's not something that you can, the eval itself like is not something which is very straightforward. I have seen
Hmm.
people starting to build saying that, oh, like, these models, like be it Gemini Pro or like Llama 4 or Quen models, they perform in a certain manner for the benchmarks. But then when you actually put them into production for your use cases, you're like, it sucks. It doesn't do the job that we wanted to do because it's probably custom data, custom tasks. It doesn't have like much depth into the subject matter expertise of what you wanted to do. So that's when it comes to like, oh, now we need to uptrain it, we need to retrain it, we need to give it access to more data. Do we need a RAG or do we not need a RAG? So it's a complicated process, and I would say like that entire journey of going from like prototyping to actually putting them in production is not consistent across different use cases. So
I agree.
no standardization, you know what I mean? uh,
Yeah,
so it's still a lot of experimentation. It is still a lot of best practices being shared in terms of how educated your leads are. So if your tech lead is like really understands the space really well, they would be able to like accelerate this process to get to the final state faster, compared to if your team is not uh, tech savvy for like the AI systems, they'll probably like take it longer, or like they'll have like more iterations to get there. So it's still very subjective, but from an ROI perspective, there's very clear things, right? Like every business cares about the bottom line, which is money. This money can be like, hey, does it save me money upfront? Is that something that the model is able to do, like as being part of my product? Or does it help me reduce the man hours that is being put on something, and indirectly it helps me like save money because now my workforce can do other things than what they were originally doing. So those are like the two basic pillars, which is like how does it improve your productivity, that is like an indirect cost saving, or how does it contribute to your direct cost saving.
yeah. I think another dimension that people normally fail to think about upfront and then realize it once they have built a product is the uncertainty that is inherently present with working with LLMs. So LLMs are not like deterministic systems, so they will tend to misbehave, right? And that might actually be a big problem in certain domains. Like think about healthcare, legal, or something like that. You cannot have the LLM hallucinate, but at the same time you cannot that it is an inherent thing about LLMs. LLMs will misbehave, they will hallucinate. So you need to have like a system. When you're building a system with these LLM models, you need to build a system that is tolerant of these uncertainties, wherein you have some sort of a what to say, you need to have guardrails in place, and then you need to have evals in place so that you're constantly monitoring what the uncertainty is, how often it misbehaves, and then that way you're able to fine tune a system a little more. So those are all things that you actually land upon only when you get past the prototyping stage to the production stage. And those are actually some of the things that require some sort of intuition around how an LLM works. What are
Yeah.
the actual things that go into a transformer model, right? So if you just understand it just one level deeper, then you're probably able to work better, right? Have better quality prompts, and every step of the way you're going to be able to add something, be able to fine tune it a little more, so your end result is a little more in line with what you're trying to achieve.
Yeah, absolutely. I'm actually like seeing some interesting questions here. So I'm going to pull that up. So Ashwati says that prompt writing is going to be the next big thing. It is amazing to see that see is one of the implementations on how the responses change the order of instruction, and changing that in the system can change your results. So what do you feel about prompt writing in itself? Like, where do you see, like, I know at some point in time we were like, oh, prompt engineers is going to be a huge job role, which I personally don't see companies hiring specifically for prompt engineers. There's probably like roles which, where your like your day to day is writing prompts, or like people like working on system prompts, but I don't see companies hiring for prompt engineers. Like, maybe I'm wrong, like maybe I'm not seeing it. So what are your thoughts on that?
So here's the thing, right? Here's the analogy that I often like use when I'm trying to explain this. First and foremost, I think that prompt engineering is the most important part about building AI systems, because the kind of prompts that you write, at least given the state of the art today, really, like, to a big extent, determines your output, the quality of your output. But
Yeah,
that said, prompt engineering, I agree with you. Prompt engineering is probably not going to be a specialized role. It's
yeah,
like, what is prompt engineering? End of the day, it's communicating, it's speaking, right? It's like saying that you're going to go walk into a job interview for a data scientist, and you're going to expect them to hire you for your ability to speak English.
yeah,
No, that's not going to be the case, right? It's assumed that you know how to communicate, you know how to speak English, but then people who are able to communicate better would probably be better at their jobs. So that's how I see prompt engineering.
and where do you see these fit in the roles? Like, do you see it most often fitting with like AI engineer roles who are also doing prompt engineering? Yeah, coming back, because I don't see companies hiring where the role just says prompt engineer.
Yes, they're not going to hire a prompt engineer specifically, but then I think that you're right, right? It has to be the AI engineers, the people who are building the system, the people who are trying to fine tune the LLM towards a particular output.
Yeah,
They need to understand the fundamental principles that guide a good prompt,
yeah,
and accordingly, like, design their prompts. I think, like, since it's been a while since we've been in this world now, and probably everybody is sort of to some degree familiar with prompt engineering. So there are also a lot of patterns that can be reused, a lot of research around prompt engineering. And in general, I think that it helps to be aware about these things and integrate it into your development.
yeah, absolutely. And I feel like this also like connects to another question that I see on the comments, and it fits very well with like LLM ops, right? Because prompt engineering is not like a one standard golden rule that applies to any system that you're building. They would be subjective to what kind of input data that you're having, what kind of application that it's being integrated in, what are the intermediary steps that the pipeline is taking, not just the model, like the pipeline is taking, and then it goes through the model for processing. And most of the systems that we're seeing today is not run by one LLM. It's a combination of
Hmm.
different models. There's parts of the pipeline that's being handled by some smaller models, some open source models, some closed source models, some VLMs. So it's a combination of different things, and in each of these steps there is prompt engineering, right? So it's the engineering practices, I would say, is not like a golden rule. There's best practices to it, but it's not really like a golden rule of every prompt has to be like this, because it's very subjective to
Yes.
what that pipeline expects, what it looks like, what are the constraints of what the output should look like, what kind of data is it going to process, what kind of format should it maintain, and stuff like that.
Yeah, and it's also going to change as models get more smarter, right?
Yeah,
So what I'm also realizing as I'm working on a few projects is that sometimes when I just even if I throw in a rubbish prompt, all right,
yeah,
a prompt that does not have a lot of context, but I use a stronger model, like say Gemini 2.5 Pro or something like that, it's still able to do a really good job,
yeah,
right? So, and the models, if you assume that the models are going to continue to get better, then
yeah.
the way you prompt is also going to change.
Yes. Yeah. Yeah. Absolutely. Absolutely. And I feel like somewhere inherently that also happens in most of the models, right? That it does refine the prompt that the user provides. So
Yes.
it's always like a two-step approach, even though you provide, say, like a in like there are times when I'm just like typing fast and I misspell certain things, or like, it's just not formatted well. I'm supposed to add pointers, but it doesn't have pointers, but the model still understands. And one of the ways that I figured this out, that there is like a prompt engineering happening on the back end of the model as well, is um I want to say something, but I'm not very descriptive about it. So I just tell the model whatever I have in my mind, and I tell it to craft a prompt for me. And it's a sorts of like, fills out the gaps and like adds more
Yes,
details to the things that I would have missed. And I'm like, yeah, it's doing that next step of prompt engineering on my behalf.
correct. Yeah, but actually, tell me this. I'm actually also curious about you know the different ways you can fine tune an LLM, right? So I think on the lower end of the spectrum, the low hanging fruit and the easiest thing for you to do is prompt engineering. That is fine tune your prompt till your LLM gets to some sort of an output you're expecting.
Yeah.
But that definitely has like a ceiling, right? You can only get that far with prompt engineering. So at what point do you think engineers should start thinking about more advanced techniques like fine tuning and so on?
I would say most of the cases require you to do fine tuning, especially if you're like looking at a industry specific use case. If it's something which is general tech, like let's say I want to something like as simple as ChatGPT, right? Like if it's a general purpose technology, most cases you can get by with prompt engineering. But if it's a specific use case, then you need to get into the fine tuning part. And most of the enterprise companies that I have worked with always fine tune their models. So the basic fine tuning is that they have their own data set, or they create like a synthetic data set. Now you have like toolkits like Llama launched their synthetic data generator kit. So you have tools like that which helps you generate a synthetic data if you don't have a data. So what you're doing with fine tuning, which is the base level fine tuning, is supervised fine tuning. You give your model a set of input, output, what it should look like, and then you do a supervised fine tuning on top of that. And people who are familiar with like traditional machine learning, it's very similar to transfer learning, where
Mhm.
you don't need to like there's obviously like two levels of fine tuning, right? Like either you do a full fine tuning where you're changing the model parameters for the entire model, but most of the model right now are like having billions of parameters, so it's very compute intensive if you want to do a full fine tuning. So people opt for a parameter efficient fine tuning, which is similar to a transfer learning. That's the closest analogy that I can think of. But what you're doing is you're introducing additional layers which are adapter layers, and then you just fine tune those layers, and then that
Mhm.
gets added on to your main model, and then it's served as a newer model or like a new version of that model. Typically all the enterprises that I'm working with are doing this in some form or the other, every single one. Then there's advanced versions of these where they're like, okay, this is good enough for now, but we have this data corpus which grows every week, so we
Mhm.
want the model to have access to this data. But obviously we're not going to do this parameter efficient fine tuning every week. So that's when they build like a RAG system around it. So which is a combination of fine tuning and RAG. So it's not like one or the other. You have like a combination of both. Yeah, then that's the more advanced methodologies. There's
So
like
in the levels, sorry, go ahead.
no, 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 go ahead.
No, so quick question over there. When in the levels of like, let's say, model tuning, right?
Mhm.
Would you say that you should attempt RAG before fine tuning if it's feasible?
It's yeah, most of the cases it's going to be extremely easy to test out RAG before fine tuning because sometimes it's I would say like it's harder to know if the model is responding in a certain way if the data is not very different from the data that the model has been trained on. So if I'm asking RAG to like go through say like my personal notes and give me answers based on my personal notes, it'll be easier for me to judge if the model has
Hmm.
access to that information, if it's working well, if the data is very different. But in situations where the data, it's able to fetch the data, but it's still crafting the responses using the model weights that the model currently has. So the style of it or the processing that the model is doing it based on the model weights that it has been trained on. So 100% I would say like start with RAG, but a lot of times people don't have like a huge data corpus that they want to like train it on. Most of the times they have like a smaller supervised data corpus which they want to fine tune it. So it depends on like what you have mostly accessible. But typically if you have a data corpus, you start with RAG, you just attach your model to that RAG pipeline. Most of the model providers or like platforms like Vertex AI have it like out of the box. All it needs you to do is like connect it with the data source, and then you can run a RAG and test it out. The second one is slightly more compute intensive, because you need to have like a model deployed which has access to fine tuning capabilities. So the model provider have to give you access to that capabilities in order for you to like fine tune the model. So once you've tested that out and it still not is not responding in the style that you want it to be, or the format that you want it to be, that's when you go ahead and like fine tune.
Yeah, that makes a lot of sense. Um,
So I have
so
a
about
question,
yeah,
like,
go for it.
because we were talking about like, prompt engineering and how it relies on ML ops. How do you see like ML ops have evolved in the last couple of years, and like what are the different components of LLM ops that you see that adds on, like that engineers should learn about?
So I think so the as I said, right, I think that in the past, ML ops was very like, data pipeline heavy, right? And today it's kind of morphing more into a space where it's about, trying to optimize your inference, and more importantly, it's also about observability. ML ops, observability was a thing back in the day with ML ops as well, where we have. I think it was very important for you to look at your model drift and so on to just see how your model is performing in production. But then today, I think that with LLM and some of the things that you highlighted today, right now about okay, how do you make the decision for when do you have to go ahead and fine tune your model, when do you if your RAG system is performing well and all of that, that actually comes from a lot of evaluation and a lot of using like a lot of sort of basically creating your evaluation metrics, designing your evaluation metrics, and also using platforms to kind of investigate how your model is performing while in production as well. So I feel like at least in based on my experience, that's where I am focusing on a lot more today.
Yeah, that's 100% fair. And how do you see that like changing with AI agents? Like, let's get into a little bit of that, right? Like we are moving away from pure LLMs and moving towards like AI agents. Um, Previously we were discussing that, like we have completely shifted from like a single LLM workflow to multi LLM workflows, and that has also like now shifted to like agentic AI, where most of the agentic AI, when people would say agentic AI, it's all about tool calling, right? Like how many tools can you give access to your model, how well can it do tool calling. So how do you see that transition going from like ML pipelines or like LLM pipelines to agentic AI systems?
Yeah. So tool calls is a very like LLM domain specific concept, right? Like that's what is like really like changing the game today, wherein you have your LLM as your base level reasoning engine, and then you're able to expand its capabilities using tool calls.
Yeah.
Uh, just a quick check. It looks like you're frozen on my screen, so I just want to make sure that you're
Oh,
there.
wait.
Okay, yeah, I can hear you. So maybe your video is frozen. Okay, great. So talking about tool calls, right? I think that with the traditional ML models, right, you were not thinking about it in terms of tool calls. You are building a model for one specific task, right?
Mhm.
And you were just concerned about, whether that model is performing the task, and then you would go ahead and evaluate the model and check the accuracy of that model against that task. But
Yeah.
then with LLMs, it's more of a general purpose model, right? You can actually use it as a reasoning engine, and with tools, you can expand its capabilities, right? And that's what's really creating the unlock today, because when we talk about agents, we're also talking about basically what you're trying to say is today we can build autonomous systems
Yeah.
wherein not everything is deterministic, not everything has to be an if else sort of code. You just give a complex task to the agentic system, and it's able to autonomously like figure out what to do, figure out which tools to call, and so on. So yeah, so I feel like that's been like the main like shift in the whole like way people are thinking about developing systems today. That's why it's also a very exciting space to get into, because a lot of the traditional way that we were thinking about building software is slowly changing, right?
Yes.
I say slowly changing because there are still a lot of trade-offs. You can't completely go from a deterministic world to an autonomous world,
Yeah.
right? But you could definitely see like certain areas that would really benefit from this kind of a framing and these kind of solutions.
100%. And I just want to mention this because I've seen a lot of people getting confused when people say agentic AI systems. They are like, oh, so it can do whatever it wants to do. Well, it can do whatever tools you have provided it to do. And second thing, which is also very important, is that your LLM should be highly capable of tool calling. Which recently with Quen 3 we saw that it's better at function calling compared to the others, because there is a caveat here, right? Somewhere having that deterministic stateful automation is also important, because when your risk appetite is zero and you're like, no, I cannot risk like even 0.5% of the times that the model is not able to call the right tool. Because that's what happens when I'm prompting the model something, the model is actually reasoning and it decides if it wants to call a particular tool and which tool to call. It automatically reasons and decides like what is the parameter that it should call the tool with, like what are the like context information that it should call the tool with, and then it goes and makes that call.
Yes.
So that part is not deterministic, but that's also a caveat. I feel like even though it's easier, but you're still relying on the common sense of the model to decide if and when a particular tool call should happen. And that's, I feel, a very genuine concern that some people might have, that, okay, what is the fallback? Like, what if in my giant, huge, enormous system, I wanted the model to do this particular function call at this particular time, but for some reason it decided not to.
Yeah, so that's very very interesting, right? That's also such a complex thing to solve for. And interestingly, I think a lot of this comes down to your design choices. It's how you're going to
Yeah.
architect the system. First and foremost, I think the rule of thumb over here is that do not use LLMs, do not build agentic systems when you don't need them. If you
Yeah.
feel like there is a simple, easy way to build deterministic solution for a problem, I think we should all like lean towards doing that and just identify the areas that would benefit from some sort of an agentic pattern. This would basically mean like this situation has to be like complex enough where you cannot predict upfront what are the various like scenarios and possibilities, right? And yeah, the ability of the model matters a lot in being able to like call a tool particular tool calling ultimately is a model's ability. It depends on how well it's trained to be able to identify and call it. Some of your fundamental principles of prompting and all of that matter over here, because you give a system prompt, again, like reiterating the various tools that the mod is available for you, and you kind of give it a sense for what tool to call in what scenario, the model will probably do it for you. And also, I think that as the problem space gets more complex, you got to like start building out your agentic system in a way where it's like more smaller domains. Every agent, every smaller every domain will have an agent that's kind of like just dealing with that. For example, let's just take the common ones like flight booking, travel agent, and some other agent that can only, like, let's say one agent is able to book flights and the other agent is able to like go ahead and research places. You don't want just one agent doing all of this. Rather, you design your agentic system in a way wherein you have one agent that just like determines what's necessary, gets the user's request, and
Yeah.
then decides which agent to like kick off, and which agent to like sort of send on a mission to do a particular task. So that way you're reducing the problem space at each level of the workflow, and those are all like sort of design choices. And
Yeah.
that's why it's so important to be able to like architect great systems.
Yeah, absolutely. And I think like now the creativity or like the optimization is not so much at the model level, it's rather at this architecture level. Like, how well can you break them into like master nodes and worker nodes, and what are the fallback options for the worker nodes? What kind of model choices do you make for these worker nodes? And that also like gets me to this question, which I feel like is a great question that this person has asked. um, Sorry, just scrolled past this. So Anirban is asking like, when do you choose between like an open source LLM or like a closed source LLM? And I'm going to combine it with one more question that I see on the chat, which is like, when do you choose between like small language models versus large language models?
Well, so the open source and closed source one, I'll actually let you answer it. I don't have a lot of experience with that because I've usually worked with closed source models.
Correct.
The reason being that we have typically worked on like smaller scale projects. I'll just give you my experience, and you can share your thoughts as well. With smaller scale projects, and with smaller budgets, then what you're trying to do is you want like a solution that's best in class, and you want to be able to build things easily with just API calls, right? You don't want to you don't want the hassle of trying to sort of host a model, and then trying to
Yeah.
fine tune the model and all that. You don't want to do that,
Yeah.
and you just want to build workflows using the best model that's available today. And for those cases, I think that closed source models are actually great. uh,
Yeah.
I feel, I just based on my reasoning about it, I feel like if you have like sort of strong feelings around privacy and all of that, then it might make sense for you to like lean towards an open source model that you're hosting internally and so on, right? And sorry, what was the second part of your question?
Second part is like, when do you go for like a smaller sized model versus a larger sized model?
Yeah, you would always want to start with a smaller size model, right? As long as it's getting the job done, in my opinion, at least, because it's faster, it is cheaper, and it's just like the best way to go about it. So I would say like start small, and then you'll automatically know when you need a more powerful model, right? You start small, and then you see it misbehaving, it's not aligning with your
Yeah.
desired output, and then you upgrade the model. And if you're using a closed source model, something like an open AI model and all of that, you just have to swap out the API call that you're making,
Yeah.
right? You just have to swap out the model name, and those are all like really, like, I would say, advantages of using closed source model providers.
Yes, absolutely. And I like going back to the closed source and open source, right? 2 years from like 2 years ago, open source models, nobody really cared about it unless you're just like building a project for your university, because purely because of the quality of the model. And
Hmm.
now I feel, with after the DeepSeek V3 and R1 came out, tables have turned, and a lot more people are considering using open source models for two reasons, right? Like, simple thing: if I'm a founder or I'm working at a company and I want to build a toolkit that uses LLMs, I care about two things, which is, one, how good the quality of the model is, and second, how expensive is it going to be for me to use it, right? That includes like the hosting cost or like out of the box cost or whatever it is, right? Like the entire cost, like maintenance cost or like one time cost, whatever it is, right? And from the quality perspective, for the longest time, proprietary models used to win in terms of quality. There was not even a comparison of like how closed source models and open source models would work. But now the tables have turned, and now that this entire like knowledge base is available as open source, which is like the model weights are available for you to use for free, it's very high quality. It gives you a lot more customization, so you can build your own distillation of the models. So you basically like extract
Hmm.
the smaller model out of the larger model and like customize it for your own use cases. Fine tuning is much easier. Third thing is like, you get choice on deciding where do you want to host the model. Do I want to do it on prem? Do I host it with Google? Do I host it with like Hugging Face inference providers? Do I host it with Fireworks? Whatever it is, right? Like, you get that choice of what should you use to like host the model. Third part, you, as you said, like having that control of privacy. You hear from the model providers typically that, hey, we provide you with a secure environment, but it is still a vendor lock-in. At the end of the day, it is still a vendor lock-in, and you still have to do a lot of connectors between your internal systems and their systems. And I was speaking
Hmm.
about this with one of a very senior exec at LinkedIn, and they are experimenting with a lot of like large language models. And from day one, their expectation was that we don't want to use a cloud provider. We want the model to be hosted on our on-prem systems, and that is going to be the case with a lot of enterprises. And in that case, the clear answer is open source models. So that's like my perspective on like open source and closed source. And like I
Well,
would
let me ask you this, right?
yeah,
Like, if you're a founder,
yeah,
a startup founder, and you're just beginning to like build a product that
yeah,
is very new in the industry,
yeah.
and it's an AI product, right? Which approach would you recommend taking?
Right now, if I would go for open source models, because it's way easier to test right
Hmm.
now. Again, if you were to ask me this a year ago, I would have said OpenAI because the API accessibility and the SDK was extremely easy for me to do. But now I feel
Hmm.
I get the same level of developer experience even with open source toolkits. So I would go ahead and do that because it just gives me a lot more flexibility into testing out the models. That being said, I would never, never, ever, try to blindside myself from the closed source models. That's not the goal. There is basically like pros and cons between any of the models that you're choosing, and at the end of the day it's about like how good your application performs, right? So it's all about benchmarking it for yourself. Sure, there are like third party providers which benchmark these models for general data sets, but then I would say, like any startup founder, I would say, like whatever you're trying to build, always try to explore all the options that is available to you. Benchmark it yourself, have your own evals, try to run different models, be it closed source, open source, see how it performs for your tasks, and then make a call. It's as simple as that. Because now, like the developer experience is pretty much the same. So, whatever you can do with OpenAI SDK, you can do with any other open source model SDK.
That is true, actually.
Yeah.
Yeah, very fair.
Yeah.
So going
And
back to,
now
go ahead.
yeah, yeah, go ahead. No, no, you
No,
go ahead.
I'm curious to hear what you are. I feel like you were onto
I
something
was
interesting.
I was going because I'm just like seeing some questions, and I wanted to like just answer them as well. Like while we are moving away from like function calling, right? When MCP came out, the entire conversation was that, oh, it changes the way that agents are being built. It standardizes the process of how models interact with tools and with multiple different other LLMs and stuff. So it did change the entire ease of use for building AI agents, but fundamentally, it is still function calling at the end of the day. It is just standardizing that and encapsulating it in a way that as a developer, you don't have to worry about how the nitty gritty of those connectors would look like, but that's available to you out of the box, right? So, what has been your experience like using MCP versus like before MCP when you were using function calling?
Yeah, so interestingly, right? There's I know that there's a lot of hype around MCP, right? Everybody is talking about MCP, but when you actually peel the layers, you realize that MCP is actually a very simple thing. It's just a protocol. It's just like a standardized way for you to do function calling,
Yeah.
right? Uh, but it comes down to this, right? I feel like if you're in a universe where your LLM needs access to over, like, say, 100 tools, 100 functions, right? And let's also say that you don't have control over all of the functions. You're not the one developing all of the functions. They're probably across different systems, different teams, and so on. Then you would definitely benefit from using MCP, because it just like offers a very standardized, a very scalable way and a neat way for you to interact with these systems,
Yeah.
and it's so low effort. Although there is a little bit of an upfront, like, overhead in terms of like actually development overhead to like integrate your systems that you might have built with function calling to like migrate over to use MCP. I would say that it's completely worth it. But then if you're building like a smaller project, right, like without a lot of dependencies, and you just have to call one, two, three, or even 10 tools, then I think it comes down to actually having a sense for where you think this product will be in the next 2, 3, 4 months or a year, and see at what level it's going to grow, right? If the number of tools that an LLM is going to call is going to be like very low or very less, and if it's all going to be like within the same system that you're building, then you probably want to use function calling, because it's faster, right? You don't have to deal with the overheads of the transport layer that comes with an MCP and all of that. So it's nice that you have both the options available to you. And I think that as the more sophisticated and the more like interesting products will definitely get built with MCP.
Yeah. Yeah. So if you were to talk about like, a software engineer who's wants to like transition to an AI engineer in today's day, what would the recommendations be? Like, what are the concepts that you would say that start with these?
Yeah, so that's a good question. In fact, I was thinking about this the other day. I feel like today, like, since I worked so much with machine learning engineers, I feel like that is the role that is morphing a little, right? Like that is the role that is becoming AI engineers that we are like kind of like calling ourselves today. And it's easier to be an AI engineer today because you don't really need to get into the weeds of a model building itself. So I would actually split that space into like two domains. One is if you are the one building these models, if you are the one doing fine tuning, and you are the one who's like building the next you know O3 or like the next Gemini model and so on. If you're on one of those teams, then I think that you definitely need a different skill set that is more like mathematically grounded and understanding these machine learning concepts from ground up. But if you're just the person building software systems,
Yeah.
agentic software systems and AI driven software systems, then there is plenty of opportunity for you to make that transition easily from a software engineer to an AI engineer, right? And all you need for that actually is familiarity with a few principles, just at an intuition level, right? Just understand how these LLMs and prompt engineering and all of these things work, and it's really easy to gather that knowledge. And secondly, I would also say that you need to develop familiarity with a few popular frameworks,
Yeah.
right? I would say LangChain and LangGraph is one of those frameworks, right?
Yeah.
It's almost like picking up React or something like that for web development, right? And then also like understanding what are the various cloud providers, and so for example, if you're talking about the AWS stack, Bedrock is their AI service, and just
Yeah.
understanding how you can build with Bedrock are all like things that an AI engineer should do to be able to, or a software engineer should just kind of like get familiar with
Get
to
familiar.
be able to effectively start building uh, AI products.
Yeah, absolutely. Absolutely. I would 100% say the same. And um, also, like, I feel understanding how the connectors work, like, how do you build like a multi-arm system, which is not just like relying on one model, one set of tools, but it has like access to plenty of different like connectors that lets it fetch multiple different kinds of data, lets it
Yes,
like maintain the context, lets it like have that memory. I feel like memory, like I recently met this founder of Mem0, which is
M0.
basically
Yeah.
like a memory company. And I feel that's also like such an important part of this entire agentic systems on how do you maintain memory, right? Context, I feel at some point in time we saw that when Llama 4 launched, people, I would see these like ridiculous posts on LinkedIn saying RAG is dead because context window is like 1 million for Llama 4 Maverick. And I'm like, oh god, that's not true. Having larger context window helps you save your effort and time for chunking the data, but there is no way an enterprise can fit their entire data set in that 1 million token
And
context.
it's also the context window is not persistent, right? That's also
Exactly.
another
It's not
thing.
persistent.
Yeah.
It's not persistent
So
because every
yeah,
time
so
you
that's the
have
thing
like
with.
a follow-up payload, right? Every time you have like more context being added to the chat, it's going to eat up on the main context window. It's going to like overlap on that.
Exactly. Yeah. So yeah, things like memory are also key. In fact, that's the thing about LLMs, right? They're like brains that have Alzheimer's, because vanilla LLMs can just like take a user input at one at a time, and then like provide an output for that user input, and then that's it. It forgets about it.
Yeah.
All of the other stuff, right? For an LLM to actually work like the way that you're used to it working on with ChatGPT and so on, wherein it's able to have a conversation with you, all of that is actually systems that's built outside of an LLM. You orchestrate the memory and so on, and maintain that context for the LLM, so it can sort of look at all the conversations that you had ahead of time. And those are all software engineering concepts if you think about it.
Yeah.
You just
Yeah.
need to understand those patterns. You need to understand like how these systems get built, and then you're able to sort of uh, go out there and like build the next ChatGPT and so on.
Yep, absolutely. And I want to definitely like talk about the workshop that we're putting together, right? Like last workshop that we did, I felt it was like one-off workshop that we wanted to do, and we were like, oh, we'll just do a vibe coding workshop. And on through the workshop, like we got so many comments about, hey, help us understand agentic systems, help us understand how MCP works. There's also like it's not something that we can really put together in like one workshop because there's so many layers to it. And we don't want to do it in a way which is like level 101 for all different topics. Rather, we want to like break it down where we go really deep into like MCP and really go deep into like agent to agent systems and stuff like that. So um we have put together this MCP workshop, which is happening next Saturday. And yeah, like we wanted to cover everything around like how do you build MCP system, like the systems using MCP. So how do you use the off the shelf MCP servers? Plus, we have like hands-on session on how to build your own custom MCP server. So Arvind, do you want to explain like to people maybe what an out of the box MCP server is, like just like general of like what the architecture looks like?
Yeah, sure. So the way MCP is set up today, right, is that you have it's a client server architecture, wherein we just spoke about how LLMs today work heavily rely on tool calls to extend their capabilities. So what MCP is proposing is that, hey, you create a server that can, basically host all your tools,
Mhm.
and whenever an LLM, which is on the client side, requires a tool, it can just request the tool from that server, and it will the MCP server will be able to, like, provision that request. So that's,
Yeah.
in a nutshell, in very, like, in a very diluted way, that's what an MCP server does. And with MCP, there's also an option to, like, either, like, host these servers locally on your own machine,
Yeah.
or also, like, host it on the internet. Like,
Yeah.
for example, if you are GitHub or some other, like, major enterprise, and you want to provide access to your internal systems. Today, most of these big enterprises, they already provide API access, right?
Yeah.
But API is good for, like, traditional programming.
Yeah.
What LLMs really would need are tool calls. So you can think of MCP being that, sort of a interface for
Yeah.
LLMs to go and access tools from a well-known service
Yeah.
provider. So that's the idea. So just kind of like bubbling up again, as Aishwarya was talking about it, right? I feel like what we want to do with these workshops is that we want to just give, like, that intuition that you need to be able to just, like, when you see these concepts and when you see them working, or also understand, okay, look how it looks when you peel the layers, and how exactly these components come together. It really enriches your knowledge about, okay,
Yeah.
how all of these things work together. And at the same time, I hope that it gives you a sense for, like, how easy all of this is. Usually jargon sounds a lot more complex than what it actually is, and that's kind of the mission that Aishwarya and I are on. We want to just kind of
Yeah.
demystify this to the extent possible, so more and more people can start to appreciate how easy it is, and make that transition into, like, a world with which is AI first.
Yeah. And the other thing that we have been focusing on both, it was for the vibe coding workshop as well. We had like two hands-on demos that we had for the vibe coding workshop. One was with Replit, where we were building a website. And the second one was with Cursor, where we were actually like building backend code. So the goal is to not just like tell you theory, but it's for you to like understand what tools to use, how to use them, what are the best practices. I feel that's more actionable. Like if I were to learn, I would want a course like that, which tells me like how do I get started? Okay, like I understand the principles, I understand the architecture, but how do I get started? What's step one? Like how do I really put things together? And at the end of the day, I have a project to showcase, and that's what we have been doing for our vibe coding workshop as well. And even for this one, we have two different hands-on projects, which will be something that you take away and you can build something out of it on your own. So if you're somebody who's like, hey, I want to transition into AI engineering and I would like to have some like interesting portfolio projects for myself, that's also like another output that you can get with this workshop, which is get a really good project out of it.
Yeah, absolutely agree. In fact, this reminds me of a conversation that I recently had with somebody, and one of the things they said stuck with me, right? So they said that, gone are the days of structured learning, where you sit in a class, and you go through theory and curriculum and so on,
Yeah.
because learning happens in different ways today through AI. But the best way to learn is through actually, like, working on projects, and, like,
Yes.
kind of
100%.
leveraging AI to, like, help you build, and you can build a very fast today.
Yeah.
And we are just, like, trying to give you enough resources and enough of a bootstrap for you to able to, like, quickly start building, and get more deep and familiar with these AI technologies.
Yeah, absolutely, 100%. And I feel like it just is helpful when you understand like what are the commonly used tech stack, because uh, there's always like so many options out in the market and you're confused that, hey, should I be using this tool or that tool? Like, there's 20 different options for me to do the same thing. So how do I choose between the tools which is available at your disposal?
Yep.
Yeah. And yeah, if you have recommendations on like, what other workshops would you want us to build? We have like a few ideas in our mind. But yeah, we're always open to feedback because the entire goal is for us to build the content that you are looking for. So if you feel that, hey, these are some of the topics which you would like to learn, like feel free to add that in the comments and we could plan to see how we can make that happen. And yeah, I'm just going to add the link to the workshop in the chat. So if you want to join us, it's happening on 31st of May, 8 a.m. PST. It's going to be 3 hours. The last time that we did, it was supposed to be 3 hours and we went on for 4 hours because the last hour and a half was answering all your questions. We literally went through each and every question which was there in the chat and thoroughly answered all the questions. So hopefully we'll try to keep it a little bit shorter this time. But yeah, it'll be a 3-hour session.
Yes, it'll be fun. I'm looking forward to it.
It'll be fun, yes. Cool. Awesome.
Cool.
And yeah, like always up for ideas. If you have any ideas in your mind, feel free to throw it in the chat and we'll get to it.
Yes,
Cool. Amazing. Thanks, Arvind,
this was fun.
for
All
joining
right.
us.
Thanks, Aishwarya.
We
Yeah,
should keep
thanks
doing more.
everyone for joining us. We will definitely do this, right? And we'll do more of this so we can just like, as and when we learn new cool things, we can share it
Yeah.
with everyone.
The way that came up is because during our calls, we talk about so many interesting things. And I was like, dude, this should be a LinkedIn Live. So you should just replace all of our calls into LinkedIn Lives. So that'll be like beneficial for everybody else to also like listen to.
Yeah, absolutely.
Awesome. Thank you, everyone.
All
Thanks
right
for
then.
joining us.
Thank you, everyone.